John Steinbeck said, "For how can one know color in perpetual green?" As I look out across the Salinas Valleys and other agricultural fields across our nation, I can understand how somebody would say something like that. And right now, we're trying to do something so that we can keep these valleys green and continue to grow more food. My name's Penny Nagel. I'm a 9th generation farmer out of Central Illinois, and I'm the COO and co-founder of Persistence Data Mining, where we're developing technology to help farmers increase productivity by replacing chemistry with physics. Now, some of you might be looking around and thinking, what does that mean? Well, currently, farmers rely on grid soil sampling. Basically, we drive out into a field, we pull a core sample with our extremely high technology. We pull out a core sample of about 6 inches. Generally, that's about a half a cup of dirt for every 4 acres, and we make decisions that affect 32% of our input costs based on a half a cup of dirt. What we're doing is we're developing a system using hyperspectral imaging and our TerraSmart process, patent pending, in order to collect the data quickly, connect, and give farmers better information. Right now, precision agriculture is a $5.1 billion industry that, again, is affecting 32% of farmers' input costs as well as their yields. So as you can see here, we've got 4 football fields. So imagine 4 football fields, and we're pulling a half a cup of dirt to make decisions. This just isn't enough information for farmers to make good decisions. And again, grid sampling or zone sampling is basically the gold standard for making decisions. There's a lot of other technologies out there that are trying to help supplement that information, but the gold standard is still driving out and pulling that information. So our solution basically enables us to go out faster, quicker, easier, and do less labor-intensive work and pull information. We ran the numbers, and according to university research study that both our advisors as well as our agronomists have participated in, have proved that by pulling more data sets per acre, we can increase yields by 13% and decrease input costs by 15%. Last year in the Midwest, farmers looked at making a loss on their crops of about $56. By using this kind of technology, we can make better input decisions, and therefore we could have turned that loss year into a profit year by increasing the amount of money made by about $106. So our initial target market for our customers going out is basically working with California growers as well as Midwest growers and Southern growers in order to get to market. Some of the things we've learned is that this is a need across the world. So there are 7.68 billion acres available to help farmers be more profitable and increase the food supplies so that we can grow more with less over the next few years. Basically, in order to deploy, we're working with agronomic service providers as well as our testing partners. And currently, we're working with farmers that own over 680,000 acres to validate our technology across a number of different areas. One of our focuses has been on making sure that we're creating a system that's beneficial to the farmers and making sure that this is fully validated before we go out into the field and start generating revenues. We've been working with universities as well as the USDA and the public sector, corporate farms, soil laboratories, and of course a number of different equipment manufacturers, including we presented at the International Society of Spectroscopy, Photonics and Optics. We just published with the International Society of Precision Ag, and we're looking forward to further validating our technologies so that we can start offering services. Our progress to date has been collecting data samples on 11 states, 2 continents, on 10 different soil textures, in order to make sure that we know what we're doing in order to offer viable services to our customers. To get to MVP, we need to complete 12 states, 2 continents, and 14 different soil textures. And then, of course, looking down the road, we'd like to hit all 50 states, all 5 continents, and 14 different soil textures. But in order to do that, we need your help. Our financial projections are based on working with agronomic service providers that enable us to deploy this service quickly and easily. We are a data management platform where we process information so that we can feed it back to those agronomic service providers who then help farmers make decisions on their input decisions. Our use of funds, we're raising $500,000 in order to get to an MVP, or a minimal viable product. We've got 3 patents we need to file. We have 1 patent pending and 3 trademarks in the works, but we need to complete this process so that we can go out and work with these agronomic service providers, equipment manufacturers, and labs to push information to farmers similar to how they do it currently, and then they can push that information, their proprietary information, to whichever platform they choose. Our team's made up of a number of visionaries. Both Brian Zamudio and Henry Bonner have been involved in a number of startups. Brian has also been involved in cheese as well as tobacco. Myself, 9th generation farmer. Chris Totter, our data reduction specialist, who is actually part of the team that got to the deepest depths of the ocean through specialized data analytics. We also have a programmer, our PhD in agronomy, Kim Fleming, as well as our marketing representative, Warren Clark. Please look out, and both Brian, Warren, Kim, and I are here to answer any further technical questions you might have, and we hope that some of you will choose to become part of our development partners, investors, or users of our technology. Thank you.